Hi everybody, and welcome to another Kuta worksheet tutorial. Today I'm going to be talking about parallel and perpendicular slopes and how to write the equations of those lines. I'm going to start with the basics. So if you see in number 1, we have this blue line here through the coordinate plane. And the first thing we're going to do is we're going to try to find the slope by using the rise over the run. That's like the primary way people like to think of slope, is the rise over the run. The rise is the same thing as the vertical change over the horizontal change, which is the run, or the change in y's over the change in x. So as we look at these 2 points, I like to always start with the point on the left, that's there, and then I go up to get to my next point, or down. In this case it's up, so I know that my rise is going to be positive. And then it looks like I run 1. Oh, I forgot to count. So you get plus 1, 2, 3 for my rise. I went up 3 units. I went over 1. So my slope is 3 over 1, or just 3. So that's number 1. This tutorial really isn't about finding slope. You should kind of already know how to do that. So I'm going to kind of go fast through that part. If we have 2 points, we're going to label it x1, y1, x2, y2, and we're asked to find the slope again. So we're going to do y2 minus y1 over x2 minus x1. So here we have y2 is negative 16 minus a negative 10. So it's going to be plus 10. Just keep that in mind. And then we have 8 minus 2 in the bottom. So we have negative 16 plus 10 is negative 6 over 6. That gives us negative 1. So there's our slope. If it's written in this form, I'm going to go ahead and do both of these for you. We have 9 over 5, and that's just our slope because it's already in slope-intercept form, where m is your slope and b is your y-intercept. Now, you might think that for number 6, 5 is your slope, but you would be incorrect. Your slope is actually 0. This is a special case where 0 times x is your slope, so our slope is 0, and that just leaves you y equals 5, so it is a horizontal line. This is the good stuff right here. This is what I really wanted to get to. It's find the slope of a line parallel to each given line. So we start off real basic here. It doesn't give any certain requirements as to what point it needs to go through. So we're just going to look at our slope, and here it's negative 5 over 2. So we need to write an equation of a line that goes through negative 5 over 2. Now, don't do the temptation or fall into the temptation of just writing minus 2. That's the same line. Don't just write the same line. Okay, we need a different line that's parallel. So a parallel line cannot be the same line. So the easiest thing to do is just change the y-intercept to something else. So in this case, we do plus 3, and then we're done. That's a line that's parallel because it has the same slope. If you don't remember, parallel lines have same slope, different y-intercept. Y-intercept. Okay, perpendicular lines have opposite reciprocal slopes, and the y-intercept doesn't really matter. And then the same line obviously has the same slope and the same y-intercept, but that's not the case for this particular worksheet. We're just worried about parallel lines and perpendicular lines. So let's go ahead and move on to the next one. We see that we have a negative 1 slope, negative 1 over 1, or just negative 1. So we can write negative y equals negative x, and then we can write plus 10. It doesn't really matter for this exercise, and we're done. There's our line. So we can do the same thing for these ones down here. For example, number 11, we'd have to do a little bit of work. The first thing we want to do is get the y by itself, subtract 7x. We get negative 5y equals negative 7x plus 20. Then we have to divide both sides by negative 5, negative 5. Okay, this whole point of this is because we want to find our slope, because we need a slope to figure out what is parallel to it. So we get y, for this equation, we get y equals negative divided by negative is positive 7 over 5x. And then minus 20 divided by 5 is 4. It is important to find the y-intercept, though, because you don't want to make the same line. So our slope that we want to imitate or keep the same, so it's parallel, is 7 over 5x. And then our equation of a line, sorry, changing color, y equals, here's our 7 over 5x. We want to keep that the same, and then we can make it plus 8. It's just a different y-intercept. Okay, now we want to find the slope of a line perpendicular to each line. As we said earlier, it's the opposite reciprocal slope. So let's go ahead and demonstrate what this looks like. First thing we want to do is solve for y. So actually I'm just going to add y to here. That's another way you can solve. And we get y equals x. So our slope technically is 1 over 1. Now opposite reciprocal of 1, this is kind of a weird case, but opposite means we're going to make it negative. So if I'm going to change the slope here, I would make it a negative 1 over 1. Okay, and then I'm going to flip the 1 with the 1 to make it the reciprocal, and it stays negative 1 over 1. That's the same thing flipped. X equals y, and it doesn't matter about the y-intercept. You could have a same y-intercept, different y-intercept. Not too important there. Let's go ahead and do it with number 14. This one's going to be a little bit better. You'll see it a little bit more easily. So we do minus x. We get 2y equals 6 minus x. Divide by 2. Now we have to divide by 2 to both terms on the right. That's a very common mistake. So you get y equals 3 minus, and I'm just going to leave it as 1/2 x. That way it's easy to see what my slope is. We see that it's negative 1/2 x. And now we have to create a perpendicular slope. This one's a little bit easier to do because we have negative 1 over 2. First thing we need to do is we need to, whoops, let me take it green. First thing we need to do is make it positive, and then we flip it to be the reciprocal. So that's positive 2 over 1, or just 2. So now we're going to use this in our new equation, y equals 2x, and it doesn't matter what our y-intercept is. We're just write plus 9, and there we go. That's the equation that is perpendicular to that. Okay, write the slope-intercept form of the equation of the line described. I'm going to show you guys how to do this in 2 different ways. The first way, I'll use slope-intercept form. Okay, and the second way, I'm going to use point slope form, which I think is far superior. You'll see that, and I use that in other videos, especially my Khan Academy tutorials. But let's go ahead and roll with this slope-intercept form. So the first thing we want to do is we want to write down the slope that we need. So we want it parallel. Okay, and the next thing we want to do is we want to label the x and y of this point here. So this is my x, and this is my y. Okay, now, so I want a slope that's parallel to that one, so I should probably circle the slope. Okay, and I know I need to keep this the same for a parallel line. So I have negative 3 over 4. Okay, and then I'm going to write, I guess I'll use purple still. X equals y. I'm trying to write this in slope-intercept form, which is this. Y equals mx plus b. So essentially what I'm trying to do is figure out which of these I need to replace. I know I need a parallel slope, so I'm going to keep my m the same, my slope the same. But now the y-intercept is important because it goes through a specific point, which means it's going to hit at a specific y-intercept. How do we find that y-intercept? Well, we don't know what it is initially, so we're going to leave it as plus b. That means we don't know what it is. As of now, we have 3 variables, which is a problem. So what do? Well, what we do is we take the values it gives us for x, and we plug it into x. We take the value it gives us for y, and we plug it into y, and then we'll have only one variable. If we truly want to create an equation that goes through this point.
Hi, excuse me, Mr. West.
Yes.
Hi, can I please get Samantha Baker to the attendance office, please?
Yes, absolutely.
With books.
No problem. Pardon the interruption. Almost done here. So we have y equals negative 3 over 4x. We plug in these values, we get negative 1 equals negative 3 over 4 times 4, and then plus b. So then we solve here, we do 4. And then with the 4, we'll cancel out. We have negative 1 equals negative 3. And then we add b, and we have almost done. We're going to add 3 to both sides, add 3. We get 2 equals b, so that's our y-intercept. What do we do with this? Well, first let me change this to the colors to show you that it's a new y-intercept. And then I'm going to just plug this into my equation. So this gets plugged into b. Y equals negative 3 over 4 x plus 2. And there we go. There's my equation. Okay, so the first step is write it out in slope-intercept form. Y equals mx plus b. Plug in the slope that you need. So in this case, again, we want another parallel line. So in this case, we want 1/4. And then the last step is plug in x for y, x and y for x and y. and solve for your y-intercept. So in this case, what are we going to do? We're going to write y equals 1 over 4x plus, and this is our b, this is the thing we want to solve for. We're going to change the y, change the x to the values it gives us because we want the equation to go through this point. We want it to go through 5. We want it to go through, oops, that's my x. We want it to go through 4 for the x value. We want it to go through 5 for the y value. So you have 5 equals 4 divided by 4 gives me 1 plus b. So we get subtract 1, we get 4 equals b. So b is my y-intercept. Okay, now I'm not done. You need to put it all together. So we write y equals 1 over 4x plus 4, and that is my equation of the line that goes through that point. Okay, you can do the same thing with perpendicular. The only difference is instead of plugging this in, you would want to change it to the opposite reciprocal. So the slope you'd want to use for this guy would be positive 8 over 3, and you'd go through the same process. I think for the sake of this video, I'm actually not going to show you the point slope form just because it's not asking it. This is just the process you're going to do. Every time you're going to write the x, you're going to write the y, and you're going to plug those values in. So I'm going to go ahead and finish 19. We already found out we want a perpendicular slope, so we did the opposite reciprocal, as all right here, opposite reciprocal. Okay, and now we need to solve for b. So we're going to write in what we know. First, let me write out y equals mx plus b. That's what it wants, that form. Then we're going to replace y with negative 3. We're going to replace m with the slope that we want, which is 8 over 3. I'll use green for that. 8 over 3. Now our x, we determined, is going to be, red, is going to be negative 3 because we want to go through that point. The only thing we're trying to solve is the y-intercept. That's what we don't know. We're missing that value, so that's what we need to solve for. We know our x, we know our y, we know the slope that we want, so we solve from there. So we have negative 3 equals, we have, now I've been doing this kind of quickly. Let me show you just an easier way. If you are having trouble with multiplying fractions, we put the negative 3 over 1, and we just multiply top times top, bottom times bottom. We get negative 24 over 3, negative 3 plus b. Negative 24 over 3 reduces to negative 8 plus b equals negative 3. We add 8 to both sides, and we get 5 equals b. We're not done. The last step is to put it all together. Y equals our slope, 8 over 3, x plus our y-intercept that we solved for, plus 5, and that's how you do it. I really want to make another video that shows how to do it in point slope form. In case it's not asking for slope-intercept form, it's actually easy to convert it later, but I think point slope is much easier. So stay tuned for that, and I'll see you next time. Thanks for watching.